Okay, welcome back to Ansar Academy, and today we will be studying the gas pressure, like how the gas particle exert the pressure in all directions in the container, and the states of matter, which are three states of matter. First of all, I like to mention the drawing of the moving particles of solid, liquid, and gas because it's a typical kind of question that the examiner usually asks. So let me draw the solid particle. Okay, so this is the typical kind of particle of solid. An examiner usually asks, like there's a box given in the question paper, and you have to draw the particle of a solid. So as we have learned the different properties of a solid particle, that they are tightly closed, they are tightly packed, close together, regular arrangement. So we have applied these properties in order to draw the structure. As you can see, there is no space between the particles, and they have a regular arrangement, and they are equally spaced. So let me draw a solid structure, sorry, a liquid structure. So for a liquid structure, we have also applied this liquid structure properties in order to draw the whole structure, that we have known that they are loosely packed, they have irregular arrangement, they can slip and slide over each other. Okay, so we have applied those properties while drawing this structure. As you can see, there is little space between the particles, and moreover they have a irregular arrangement among them. So for a gas structure, let me draw a gas structure. Yes, this will be a particular structure of a gas molecule or gas particles in a container. That this is a container which contains the particles of a gas, and the drawing shows that they have an irregular arrangement there, and they are far apart between them. They have space between them, and they have irregular arrangement. So this is a typical kind of structure you can draw for a gas particle. Okay, this is a typical kind of question which examiner usually asks. That it states how do gas exert pressure equally in all directions. Well, for a drawing a diagram for representing it, as we know that these are the gas particles, they collide with each other, moving from one space to one place from another to another. So the typical answer for this could be, so our first point would be gas particles move freely and randomly in all directions. Keep in mind that we are expressing and we are explaining this question, that why and how do gas molecules exert pressure. This is a key statement of the question. So keeping in mind, we have to write the answer. So our first point is gas particles move freely and randomly in all directions. Yes, as we know. And second point would be they collide with walls of a container. It's actually the explanation of the first point, and the first point there, as it states that it moves randomly in all directions. So consequently, they collide with the walls of the container. And the third point would be then they exert a force, creating a pressure. So overall, they collide with the walls of container due to their random and free movement in all directions. As a result, they exert a force due to a certain kind of momentum, change in momentum. But it's typical kind of physics. But we won't go into that detail. So for this chemistry, we would be just saying that they exert a force, creating a pressure. So you would be gaining 3 marks out of it. So moving on. As we know, there are 3 states of matter. So solid, liquid, and gas. In this we will be moving on that which energy change or which state of matter change would give the energy loss, and which change would be having an energy gain. So while we are converting solid to liquid, this is a, we will write this sign, which means more energetic. As we will be moving on to gas, from liquid to gas, beginning from the solid, the less energetic particles will be moving towards the more energetic ones, as they will be having spaces between them, and they will be gaining energy. So for that we will be using this symbol, and same would be for liquid to gas, as they would be having more energy when we are converting liquid to a gas. And consequently, when we are converting back gas to a liquid, it would be a negative, this one. And similarly, from liquid to solid, negative. Negative, as it would be meaning that less energetic. So as we know that whenever we put a cup of water or cup of tea, if for example if you put a cup of tea inside the refrigerator or freezer, it gradually freezes up and becomes a solid. So what is happening actually in those particles, that is letting the particles of the liquid, of the liquid tea, to become a solid one. So this is the energy loss going on there. That's why it's converting from liquid to solid. For this we will be demonstrating from this by this symbol. Moving on, there are certain types of names. There are kinds of name that we used for the processes that involves the conversion from one state to another state. For example, if we convert solid to a liquid, that means we are doing melting. From liquid to gas, we are actually boiling, or another word for boiling is evaporation. Well, there's a difference between them. We will be moving on, and then we will be sharing further. So for converting gas to a liquid, the process is called the condensation, and for liquid to solid, it's called freezing. These are the typical kinds of words of the processes involved that are usually asked by the examiner. And if we are converting directly, like from solid directly to a gas state, this would be having a name and a process. This would be called a deposition, and it would be also represented by negative delta or negative symbol, this one. Okay, and for converting gas directly into solid, this would be having a name called sublimation, and it would be having a positive sign with it. So these are the names of the certain processes involved in the conversion of states of matter, and you have to remember those names especially. The another small topic for today is the check of purity. How can we know that a particular substance is an impure substance, or it contains impurities, or it is a pure one? So there is a check for purity. So for the first statement, let me explain that pure substances, I'm talking about the pure substances. Pure substances melt and it boils at fixed temperature. So this is statement we have to keep in mind. And another one would be that I would be giving an example, like If you consider an example of a water, of a pure water, the pure water have a melting point of 0 centigrade and a boiling point of 100 centigrade. Now if in this case, if you add an impurity, for instance, let me add in salt in that water, so what would happen and what would be the effect on that water from the salt which is added. So keep in mind that whenever there is an impurity that is being added to a pure substance, the result is that melting point of that substance decreases and the boiling point of that substance increases, like the range increases overall. So for this, melting point decreases, less than, it will become less than 0, and the boiling point would increase from 100 centigrade, so it would be bigger than 100 centigrade. So it's typical for all the substances in chemistry that whenever we are adding any impurity in the pure substances, so ultimately the addition of that impurity would have an effect. And what would be that effect? The effect would be that melting point of the substance would decrease and the boiling point would increase. So that's for it, and hope you like it, and subscribe and share and comment down if you have any suggestions and queries remaining, and we will be moving on further tomorrow. Thank you.